All right, good morning, everybody. Welcome to day two of, of computer science at home. I looked over the first assignment, and I just want to say for those who attempted to work on it, the top portion was done really, really well. One thing that I need you guys to start doing or focusing more on is a reflection form. Please make sure that when you are reflecting on the activity, that you're actually talking about or answering the questions that are placed there. Those questions are there to kind of guide you through the process so that you can understand exactly what's going on when you are creating your program or you wrote your program. So it's very, very important that you're able to be as detailed as possible. A lot of individuals lost points because they wrote just a sentence or two sentences. They didn't write clear sentences, they weren't detailed about their responses, and so that could change the difference between you getting A or B or a C. Right? Is that portion. Um, Also, make sure that you submit your notes. So you're getting credit for your notes. You're getting credit for the actual activity, um, and then a third portion will be the discussion board. So I posted the discussion board on Padlet so that individuals could communicate, you guys could collaborate and communicate with each other. That is an expectation over this 2 weeks, just like in class when you guys collaborate, allow you guys to talk to each other. There's an expectation to collaborate. You should be posting questions. So in your grade book, you will see a grade for Padlet, which involves, like I said, I would like to see you post every day some type of questions or some type of responses, a question and or response to a question on Padlet in which you guys are discussing with each other. So, um, so just make sure you're doing that. All right, so let's go ahead and move to today's assignment. And today we're going to be talking about loops, so different type of loops, and more focused on what we call a counter loop. It's called a counter loop. So, as you guys know, we have four main loops, and there's other loops too. But we're gonna focus on these four main loops because these are the four that you're gonna kind of play with often. You're gonna use often. So we're gonna focus on those four. Um, and two of these you've probably already used, and you should be familiar with. So you have this repeat loop, this first repeat loop, and what this repeat loop is this repeat loop has uh, a parameter, right? It just has one parameter, and that one parameter allows you to control exactly how many times you want something to loop, right? So you see it says repeat, and we have the 10 right here. And so what happens is if we put something inside of here, let's say move 10 spaces, and we click it, it's going to move 10 spaces 10 times. So you see this process. I'm going to slow this down and put this on so we kind of see it. If I click on it, you want to see it moves 10 exact times. So that means that it moves, it stops, then it moves, then it stops, then it moves, then it stops until it does that process 10 times. All right. Now, we have the for and so we use this loop when we just want something to run, right? Like we want something to draw, we just put the repeat times. We've used this for like drawing a square, drawing a triangle, basic shapes. But we don't necessarily need no conditions on this. We just need it to run. So we'll use this. We just need something to run. Now we have this forever loop. This forever loop is extremely, extremely important and can kind of mess some stuff up. So we have to be careful how we use this. So the forever loop basically makes our code, whatever's inside of it, runs forever. It's an infinite loop, right? Infinite. The problem with that is if we run anything infinitely, we can essentially get locked into the loop and make the program crash, right? We don't want to do that. So if I did this move 10 steps here and I put this, if I did a move 10 steps and put it inside the forever loop, it would just keep on going forever and ever and ever, right? It would infinitely move. I would not be able to stop this. If I was running a program and I had the check and I used the check button here, so if I added a control and I put this here and I ran that program, it will run forever. And like I said, we'll get locked into the program. So whenever we use a forever loop, anything that we put in there, we want to have what we call a conditional statement, right? So what is a conditional statement, right? Is important. What's a conditional statement? A conditional statement, right, controls whether something operates or doesn't. So it has to meet a condition before it will actually run, or it meets a condition to make it stop, right? So we can use it both ways. We can use it to say, hey, if this condition is met, then do this. Or if the condition is not met, don't do anything, right? So conditional statements typically involve this if control, if, or if else. If this works, do it. If it doesn't work, don't do it. Or if it works, do it else do this other thing, right? So for this forever loop right here, I'm gonna close this. You guys should be able to read this right here already. But I'm going to go ahead and close this for a second. So I'm using this forever loop and I'm going to put a conditional statement on it. So if I if the key is pressed, so let's say if the space bar is pressed, I'm gonna move it 10. So what happens is the only time this sprite is going to move, this sprite right here is going to move is if I press the space bar. So let me show you. I click here, and as you can see, this code is consistently running. So you see it's running, right? But as you can see, my sprite is not moving at all until I press the space bar. So I'm gonna press the space bar, and now it's moving. So it's moving slow, but it's moving. And that's probably moving slow because I have this on. But if I turn this off, now you can see it move, right? So bring this back, go to, I'm gonna put this on 2, right? And if I click it, as you can see, it's moving. I let go of the space bar, it stops. Where do you think this is probably used at? This type of code, this if statement, if key is pressed, is probably used in majority of your video games, right? So anytime you have a player, you think about player controls. When you have a player you want to move, let's say Mario, for example. Mario doesn't move or Mario doesn't operate until I press a specific button. But those controls are always available, right? So typically a forever loop is used in that instance, right? If I want to move Mario left or right, I have Mario in a forever statement, and inside of this, if the right arrow is pressed, then Mario is going to move 5 steps to the right. If the left arrow is pressed, Mario's going to move 5 steps to the left, or -5 steps, right? If the B button is pressed, he's going to jump, right? So that's where you'll typically see your forever loop is with inside of some controls, but there's always a conditional statement put there. So like right here, what says if key is pressed, move, right? All right. The repeat until. The repeat until is very, very similar, right? Except we put a conditional statement to end the loop. So what does that mean? We put a conditional statement to the end the loop. So that means that this loop, repeat until, will continue to run until the conditional statement is true or until it is false, right? So what does that mean? So Sorry about that. My garage just opened out of nowhere. Um, so what does that mean? That means that when we're running this statement, I can have this run. I can have this repeat until something happens, right? So let me find. So let's say we want this to repeat until um, I'm gonna put repeat until key is pressed. So what do I want it to do until the key is pressed? I want this to I'm gonna have it draw. I'm gonna have it draw squares. So let me see. Move. I'm gonna have it pin down. Let's see, it's clear. Pin down. Um, and then I'm gonna have it. I'm gonna put it inside of a nested loop real quick, just so I can show you guys how this works. Um, so it's you see I'm doing a nested loop right here. So move, turn, move, turn. All right. Sorry about that. Move, turn, move, turn. Like I said, I'm making a nested loop. Like I said, I'm gonna have it draw, and then I'm gonna have it change positions. So move 10 steps. Right. So now when I do this, I'll put this here, and we start running this. She's gonna keep on drawing. It's gonna keep on drawing until I press the key. Boom. So once I press the key, it stops. Right. So what that means is that that conditional statement is consistently running until the statement becomes true. So as long as I don't press the button, the statement is false. Right? The statement is false as long as I don't press the button. But as soon as I press the button, that means that it is true, and that loop is done. So it stops completely. All right. And finally, we have this counter loop, right? And so what does a counter loop do? A counter loop helps a counter loop basically controls what does it, it controls the iterations of a loop, right? Or controls controls the iterations of a loop. So what is that? What is the iteration? The iteration is a process where a set of instructions or structure is consistently repeated until a condition is met, right? So what we're doing here is we're having this process ran over and over and over. And what we can do with this is we can actually control what happens for each iteration. So the counter loop runs through these specific numbers, right? In this one, the normal counter loop it typically goes from 1 to whatever that number is, whatever number we choose to make it. This situation is 1 to 10. But we can have it go 1 to 30. We can have it go 1 to 50. And what it does is it counts every time it runs the loop. So the first loop or first iteration, second iteration, third iteration, fourth iteration, fifth iteration, right? And it keeps on going until it meets the 10th iteration. Now, what can happen is for each one of those iterations, we can create conditions that are met, or we could create variations for each iteration. We can control how the loops run, right? So, for example, how does this work? How would this work in a video game per se, right? Um, a great way to think of a video game is if you play, um, if you play Pac-Man, right? Everybody here has played Pac-Man before, and so Pac-Man typically had one stage, or the original Pac-Man had one stage. In that stage, right, you played over and over and over. but there were some different iterations, right? So the first time you played the first stage, or the first time you played a stage, the monsters, Blinky, Pinky, etc., didn't move as quick, right? So there was some type of program, or there was some type of condition for stage one in which said, hey, Blinky and Pinky only moves 5 steps. And then you got to stage two, and stage two, Pinky and Blinky was moving 10 steps. Then page three, then stage three, Pinky and Blinky was moving 15 steps. So each time the stage changed, each iteration, Pinky and Blinky got faster, right? So you can create code, or you can use the counter code, the counter loop, to help create these conditions where each iteration something is changing, or you can even run the same thing over and over and over, right? But we're going to use, for this activity, we're going to be using a counter block to create these different things, right? So we're going to use a counter block to create this iteration, which is multiple squares. What you're going to see is, as each iteration changes, the size changes. So each time it is ran, the size of the square changes. For the second one, each time it's ran, the shape changes, right? So there's something that's changing in the code each iteration that allows us to draw different shapes, from triangle to square to pentagon to hexagon to what's seven? I can't think of what seven is right now, but seven, octagon, etc. Right? And then this one, we have another one where the size and the position is changing. Right? So be aware that this counter loop, this counter block, right, is used to help create different, right? Create a different condition, or create some type of change, or can be used to create some type of change every time it is ran. So, and you'll figure out how to write that code so that it illustrates the change. All right. So, one thing I'll show you is um, what's cool about the the I block. And I'll show you. Let's see. It's move 10 steps. If I run it, right, we can use it simply as that, or I use other controls, because this I is a what we call a local variable, right? So we could give it some conditions. We can actually go to our variable, and you see where it says set or change. We can set or change the value of I. So if we go right here, and like you see right here, because it's not in the function, or I'm sorry, it's not in our block right now, it's not in our loop, there is no variable available here. But once I put it inside of the loop, you'll see that I is now available, because, again, as I stated, it is a local variable, right? It only operates within this loop, or within this function. All right, so what I could do is I could have this, and I could change how I counts. So that's what I'm going to do. I'm going to show you how I counts. So I could change I, and I could have this count by 1, right? It normally changes by 1, but if I put here, if I say, hey, I want I to change by 1, what this does is it starts to count by 2. So I'm going to show you how this works. So let's go here. We're going to go to looks. I'm not going to have it move. I'm just going to have it count so you can see how it works. So we're going to say, let it say I for 2 seconds. And that's it. So you can see how it runs right here. You can see it counts. It's going to count all the way to 10, right? So it's showing you every time it runs the loop. All right. What we can do is we can change how this counts. So maybe I don't want it to count by 1. I want it to increase by 2. All right, so I can do this. I can say, hey, change by 1. What's going to happen is it's going to count 1, 3, 5, 7, 9. And then because the next number is going to be after a 10, then it's going to stop the loop, right? So a condition has been met. These are conditions, or these are parameters, right? We call these parameters, right? But this is a condition. So it's going to run from 1 to 10. Once it gets to that number, it is going to stop. It is only going to run from 1 to 10. So 1, 3, 5, and that's it, right? Because it's changing by 1, so it's changing by 1. It's never going to hit actual 10, right? It's going to skip 10 and go to 11. Or I'm sorry, it's changing by 2. So because it's changing by 2 now, it's going to skip 10 and go to 11. So since 11 is out of this statement, then it doesn't run it no more, right? And again, we can change these values. So I can change this 0 to 30, and I can say have it change by 1 again. I can have it change by 2. That'll let me count by 3s. I'm going to have this just go really, really fast. So 0.1 seconds. Did you see? Or maybe that was too fast. I'll run it again. 9, 12, 15. All right. So thank you. Like I said, we're introducing. I want to introduce conditional statements as well as the counter loop. Again, conditional statements, and we'll get more into it. We're going to talk about the control flow later. So, our next tomorrow we'll talk about control flow. But I just want to introduce this to you. You're going to play with that in the activity today. You're going to build some cool things. So, go ahead and try, explore. You should be able to use the code that you already created. So, look back on your pinwheel activity. You'll see that you should have been able to your generic function, take your generic function to build any shape, right? So people were saying, I was reading some of the comments, and people were saying what the generic function did. We created a generic function to build any equilateral shape. So that's what we ended up doing with that function, right? If you take out the backup and you put it at 0, what happens is you actually just create the normal shape. You don't create the pinwheel effect, which is the longer lines around the shape. You just create the normal shape. And so if we want to create the normal shape, we just take the backup out. And then we can actually dictate how the shape looks by changing, of course, the size, the number of branches, right? And the number of branches also control the angle, right? So if you have 5 sides, then it's going to divide the angle 360 by 5, and it's going to give us the actual angle, so we can actually draw a pentagon, right? And then we could just change the size. We can actually draw a square. 360 divided by 4. If it have 4 sides, it's going to create a square, right? If we have 3 sides, it's going to create a triangle. So that's what you should have noticed when you created this generic function, that all we have to do now is just put in the number of branches, which is actually the number of sides, take the backup out, so put backup at 0, and then give it a size, right? So whatever size, we can control how big or small whatever shape is we want to create. All right, have a good one.